Over 50 years ago, Gordon Moore, who was the CEO and co-founder of Intel, predicted that the number of electronic components, or transistors, per integrated circuit would double every year. This prediction later on became true, and it is now known as Moore's Law. I am sure many of you have heard of it. Recently, though, this process has slowed somewhat. This is not too surprising because the progress of some technologies at one time or another can often hit roadblocks that take time and effort to get around. However, this means that Moore's Law is slowing down or no longer accurate as it was before, and some have said it is dead or it will soon be dead. I am fairly sure I have seen articles that have said that before. One of the reasons Moore's Law is slowing down, or a big reason, is the problem of heat. When they put more on a smaller chip, they run into problems managing heat. Finding a solution to this problem has been challenging, but now one may have been found by researchers from the University of Virginia School of Engineering and Northwestern University. The team of researchers included Patrick E. Hopkins, who is a professor in the University of Virginia's Department of Mechanical and Aerospace Engineering, and Will Dichtel, a professor in Northwestern University's Department of Chemistry. This group of researchers published their work and findings in Nature Materials. They discovered or invented a new class of material that could prevent the computer chips from getting too hot, keeping them cool as the chips get smaller. For more details on this new class of material they discovered and how it works, I am quoting from nanowork.com here. Quote, electrical insulation materials that minimize electrical crosstalk in chips are called quote-unquote low-K dielectrics. This material type is the silent hero that makes all electronics possible by steering the current to eliminate signal erosion and interference. Ideally, it can pull damaging heat caused by electrical current away from the circuitry. The heat problem becomes exponential as the chips get smaller, because not only are there more transistors in a given area, which makes more heat in that same area, they are closer together, which makes it harder for heat to dissipate. End of quote. Many experts from different fields of study got together to collaborate on this research. All of them working together was most likely the reason they got the result they did. Patrick E. Hopkins, professor at the University of Virginia, talked about this. He said, quote, scientists have been in search of a low-K dielectric material that can handle the heat transfer and space issues inherent at much smaller scales. Although we've come a long way, new breakthroughs are just not going to happen unless we combine disciplines. For this project, we've used research and principles from several fields: mechanical engineering, chemistry, materials science, electrical engineering, to solve a really tough problem that none of us could work out on our own. End of quote. This discovery was not easy to make, so that is why it probably took all that collaboration. Austin Evans, who is a PhD student in Dichtel's lab at Northwestern University and first co-author on their work published in Nature Materials, said that this new class of materials can be used for many other things besides just keeping computers cool. He said, quote, we are already exploring this new class of materials for many applications. For instance, chemical sensing. We can use these materials to determine quote-unquote sense, that chemicals and how much of those chemicals are in the air. This has broad-reaching implications. For instance, by knowing about the chemicals in the air, we can optimize food storage, transport, and distribution to reduce global food waste. As we continue exploring, we are likely to find even more traits unique to those new materials. End of quote. So, if keeping computer chips at a good temperature was not enough, the fact that this new class of materials can be used for many other things as well, makes it even more impressive. We will see how well it works for other things, and we will see how far it will advance computer technology by keeping Moore's Law going forward at a good pace. So thanks for watching, and please like and subscribe if you've not already done so. Thanks very much.